Yes, hello, can you hear me?
Yeah, we've got you. So our next speaker is Chris Kenny, who's a PhD student in political science at Harvard. He is interested in reproducible redistricting. And so for those of you who, like me, sort of find the US a bit foreign, I think the basic idea is that the districts, the congressional districts are actually a political issue. And this is actually something that is fought over. And Chris is here to show us how we can actually do this in a reproducible manner. So thank you very much, Chris.
Thank you. Can you see the slides? The standard question.
Yeah,
okay,
perfect.
Great. I was a little worried that I shared the wrong screen. But thank you for the introduction. Yeah, I am a PhD candidate in government at Harvard University, and I'm also currently serving as a pre-doctoral fellow at the law school here, trying to actually take these types of tools that I'll speak about today and apply them primarily in a litigation type of context. So after the plans are passed, there's a whole bunch of back and forth really about the political process. With Rohan's note at the start, kind of anticipated, before we really dive into the reproducible aspect of this, I want to just introduce kind of the team that I'm working with at large, but then I'll actually give a 90-second what is redistricting for the normal countries that don't do it this kind of way. But essentially we have this large team primarily here at Harvard in government and statistics, along with some scattered people at Stanford and in Japan actually. And we've come together as a group that wants to really bring these modern redistricting algorithms, these types of samplers that allow us to try and talk about the space of legal valid plans and bring those so that researchers, policymakers, journalists, and really just the typical data scientist can use these tools and try and make an impact on their own ability to be represented in government. Before we dive into really the technical work that goes into that, first I just want to say, what is redistricting in case you come from a normal place or just really are not politically interested? What is redistricting? In the US, every 10 years, the Census Bureau conducts this massive census, a full enumeration of the population. And then they go out and they actually calculate how many seats in our federal legislature, Congress, each state should be given. You can have everyone in the House of Representatives will be given at least one seat. But how do the other seats get apportioned? In this cycle, right, we've seen 6 states got only 1 seat. And so their process is done, right? That state is your district. In the other places, in places like California, for example, they have 52 districts. And so they need to partition the state into 52 pieces. The biggest constraint on this is that those districts must have equal population. For congressional districts, it's very strict. It needs to be within a person under most situations. State, county, and city governments is actually where most of the redistricting in the United States happens. Thousands of cities and counties redistrict, whereas you only have 50 states and 149 state legislature bodies that you need to draw. With those, states and localities actually get to set what they would like to constrain on. So it's not just that they're equal population, you need to actually think about how do we do this in a way where we do meet some desirable qualities. These, once they're drawn, often undergo litigation. I would say a surprisingly large percent of plans actually get litigated. That's where you'll see breaking news like yesterday about North Carolina. It's like, so what happened in North Carolina? It's a mess. But these constraints that go into this, the starting point is that there are these kind of 3 required things that we, as we are trying to work and develop methods to work with this, always have to be very aware of, because if we aren't meeting these requirements, we aren't doing anything anywhere. And these are, the classic is population equality. The second one really gets into geographic contiguity. Districts must be like one geographic piece. There are very specific ways that you have to deal with islands, about how would you actually match those. And some places like Hawaii, because there are so many islands, have very different types of notions of contiguity. The probably biggest thing that we often think about and hear about, though, is in the United States, there's a history of segregation, a history of racial tensions regarding voting. And so when we do these types of redistricting things, we need to be in compliance with the Voting Rights Act, which means that our districts need to do some very specific things regarding minority populations. There are all of these additional types of constraints that go into this that we will want to take into account as we go through this process. So that if we're trying to talk about how plans were drawn and how they could have been drawn, that we also need to meet these types of discretionary constraints, is what we'd often call them. Things like, oh, you want to keep your county together, you want to keep your city together. These are things that I think most people recognize are not bad things, that if you have a small town, it might not make sense to split that town into 3 separate districts. You might want that to be together so it has a cohesive geographic understanding of what this member of Congress or state assemblyman, et cetera, is actually trying to represent. There's this big thing called compactness, which essentially is my shape kind of blobby, or is it this like long, thin strand? And then there come in these very specific things that you start working on a state and you realize, hey, they say we can't pair existing incumbents, and that's some sort of political nuisance, or that on the other side, you need to actually draw super competitive districts wherever you can. And so this undergoes a process that to us is not very transparent at all. And I would suspect to many people is not, where a state will have a small group that receives the data, they bring these people together, and then they just go back and forth. So where I say like opposing groups, they present, I would like this map to be the plan for the decade. And they go back and forth at that for weeks. It could be minutes, it could be weeks. And then this step 7 at the end is always, we see groups all the time sue if they lose. This process, kind of as a how do we start from this, is not very transparent. There's all sorts of process-based types of ways that we try and make redistricting transparent. So a big part of what our team at the Alarm Project is doing is on the method side of how can we make these types of things reproducible and transparent. This is happening at the same time as several types of process-based approaches are going on that are very focused on just making the process itself a transparent process. The biggest ones that you might hear of is redistricting commissions. In the US, kind of the default is the legislatures draw their own districts that they're going to draw in, that they're going to run in, right? So this is the classic picking your own constituents, picking who you want to vote for you. So many states have moved to these kind of citizen commissions that draw the maps, so that it's not the actual politicians drawing their own districts. Other big things that we're hearing a lot of now are public feedback, written justifications for why people made these choices, or requiring map drawer communication to be kind of open and recorded. The sunshine laws, if you've heard of the southern states in the US. These, however, still lack something, right? These are making the process itself type of more transparent because we're getting information about it, but we're still not knowing if this is truthful. And these are very important, very large pieces of how American democracy functions. So what our group has done is come in at this from the algorithmic side. And what I would say is we have a very algorithmic approach. And most of what we've been doing is trying to make this transportable and make it so that everyone can do it. I'll say there are 3 steps. Each of these probably has like 15 substeps. But at first, you just need to figure out what your constraints are. What do I need to do, right? So what is the state telling me I need to do? So those required things plus anything additional in the kind of discretionary category. Big step 2, generate a large sample of plans that meet those constraints. As you might imagine, that is kind of its huge own thing. But once you have that, we have something that's much clearer to think about, which is a plan good? Well, we can compare it to all of these other plans that meet that kind of legal definition. We can write down an actual target distribution that these plans are generated from, and we can begin to compare them based off of what we see. Those benefits are on very much the transparency side, that we know what information we gave the algorithm, right? If we didn't give it political information, we didn't give it political information. And we know what that was backwards, but we know what it didn't have, and we know what it had. So if we gave it information about minorities, to boost performance in certain areas and draw districts that had large minority populations in places where maybe they haven't been able to represent their candidate of choice over time. This makes it relatively quick for us to understand as well what's possible. You can click on your computer to generate a bunch of plans once you've figured out what you need to do. And you suddenly will see, well, if it exists in my sample, it can be done. It always leaves open. Maybe if it isn't in the example, you don't know if it can be done. But then the big kind of other piece here is that it makes these probabilistic statistical claims, because we're going to do this in a way that's nice and it's using sampling with different algorithms that are aimed at this. That'll help us know, like, is this proposed plan an outlier? These are the types of things that are used in that step 7, that litigation aspect, to really understand. Now with these benefits that I've painted as easy and lofty, it comes with back that huge step 2. How do I generate a large sample of plans that meet those constraints? And I would summarize that into like 5 big questions that this gives us. And that's where our kind of reproducibility really comes in, and how we want to approach this and how we are approaching this. Big question like, what data do I use? What can I actually bring to this? It needs to be open. It needs to be coming from the government so that everyone has access to the same types of resources. How do we think about things like contiguity? Places like Hawaii are a mess, right? Because they're islands. Places like Alaska similarly has islands, but actually has a much cleaner approach to how do you deal with them. Election data is often on different shapes than the actual census bureaus, shapes that are going to be used to draw the districts. How do we generate those samples? So what tools do we have for that? And then once we've done all that, how do we actually compare this plan to some of the sample plans? So our key approach here has been to, as a team of several scholars, develop a large, to us, maybe not to some of the larger ecosystems that are out there, but to develop a set of R packages that allow for anyone to really just download some data and get going and really understand what happened in this process. The starting point for that is always this, what data do I use question, right? If you don't have the data, you don't know what's going into this. And so we've set up as kind of this first stage, a package that, called Sensible that deals with US Census data. It relies on other packages that are out there, like Kyle Walker's Tidy Census, to pull in all of this data, but then it goes a step further and it uses these standardized naming conventions so that they become human readable. Those who are familiar with the Census Bureau data know that things like total population are P001001. That's not super helpful unless you are, sitting there memorizing the code book because you're working on it so often. But for other people, we want this to take that and say pop. And for things like voting age population, we want it to pull the exact correct variables that are used by the Census Bureau, that are used by the states, and call that something like VAP for voting age population. And working through several categories like that to create these so that once you open the data, you open your data frame, it's like, okay, these data make sense to me. I can understand what's in it. And then as kind of the aside to that is the Census Bureau deals in these kind of numeric codes to indicate states, to indicate regions. And so it provides all sorts of tools that work with those FIPS, ANSI, and GeoID codes. The second question that I posed before was, how do I ensure contiguity? And we've come up with a bunch of heuristic ways that, if you can see the kind of Hawaii stretching out, the way that we can connect them is to think about their geographic structure and to look at past case law so that the decisions that we're making are documented in full of how are we connecting these, so that it's not just someone ad hoc going through and saying, well, this one looks close to this one. As I said, Hawaii has some interesting rules. So like these are all counted as one island, makes it additionally weird. But then we also provide all sorts of tools that would allow you to do things like separate rivers if you're not allowed to cross a river, or separate a lake if you can't cross the lake, those types of things. Geomander's second set of tools that are in it are all about election data. So on the right here, to kind of motivate why this type of thing is a problem, I've overlaid 2 sets of lines on top of each other. One of them in black is going to actually be the state's lines. What they're saying are the basic geographic units that they're building districts out of. The red lines on top of them cover almost all of it, except for in these few areas where the state has just randomly, not actually randomly, but to the outsider, randomly split additional things. And so the key for these types of things is the election data doesn't actually match up with the census geographies that you need to work with. So we've developed a set of tools that would allow you to crosswalk between these. And there are all sorts of different ways we can think about that by, matching by area and distributing in that way. The most common approach is that we can estimate elections and estimate the vote totals down to the blocks by population and then reaggregate them up. That's probably the most common approach. But to our knowledge, before we put this together, most of that software that would do it was actually proprietary through one service called Caliper. And that can be quite a difficulty when the software is tens of thousands of dollars for if you're trying to be a citizen data scientist or researcher trying to deal with this data. Answering that really big number 2 though before, how do I generate samples of valid plans, is in and of itself a massive literature. There are dozens of papers that go through and try and figure out, okay, how can we conceptualize this type of problem and break it down and really just generate on a push go. The biggest problem that we've seen here is not the algorithms, that there are some great people who are developing the algorithms. The problem we've seen is largely, well, one group generated one algorithm and that was it. And then, so you have their random GitHub repository and that's all that you have to deal with it. Another group did the same exact thing and then put it on Dropbox. And so you can download their code and work with it. A few, like a dozen or so teams that have done these types of things. What we've gone through now and done is to collect as many of those as we can and say, okay, can we re-implement this in a common software in a common way, which gives us several different algorithms that we can work with and that we can deal with. Some of these main 2 are sequential Monte Carlo algorithms and Markov chain Monte Carlo algorithms. Those are typically what we use to actually sample districts so that we can talk about outlier status. But then there are other families like enumeration methods. If you have a very small state like Iowa that uses counties rather than precincts, right? You only have 99 counties. And you can actually enumerate every single possible district. So kind of your best of all worlds type of deal. But then there are these optimization or heuristic approaches. And we've gone and we've collected as many of these as we can and tried to bring them together into a standard interface that very keyly implements the types of common constraints that I talked about before: geographic contiguity, population equality, avoiding pairing incumbents, creating competitive districts, those types of things, so that in a, I say like in a second, but with familiarity with the software, everyone is able to then go and actually score these plans and understand what's going on. It also provides additional tools for making sure that you're doing this correctly. And then for that 5th question that I posed before, how do I compare a proposed plan to the sample plans? Well, you're in luck. Since around 1984, people have just been writing paper after paper after paper, bringing together all of these different types of ideas of what is fair to me is not fair to you, is not fair to another person. So we all have different conceptions of what bias might be, especially in a partisan sense. And so we've collected many of the common ones for these and brought them together. That compactness, this idea of, is the shape of my district round? Is it smooth? Similarly for that. And then for these more discretionary things about administrative splits, understanding segregation created by districts, or some like weird to us as political scientists, but much more common, I believe, to the computer scientists, this idea between distance between like partitions of a graph that give a lot of information about, have we created a quality sample? Have we created something that's diverse and that's actually capturing the space that we're trying to do? And to really bring these all together and say, okay, all of these packages interface with these, with the 4 that I've talked about, and with these other 4 that are like very specific add-ons, which I won't spend nearly as much time on, but like citizen voting age population in states like Texas or Florida, the way that you deal with citizenship is very important because there's a high non-citizen rate. Understanding diversity and segregation matters for how sometimes districts are actually drawn for determining, do we need to draw majority minority districts? And then 2 additional approaches for reading data, privacy protected data, and just the large data summary files. The goal of these is all to take it and be able to actually apply it and show, okay, now that we have this data, here's an entire pipeline that can be run and will actually help demonstrate, is a plan an outlier or not. Our major project right now with that has been to take this suite of our packages and create essentially templates for how would we do this across 50 states that are redistricting, the 44 that are more than just a single district and actually have a process has been our focus. With that, we've gone and done many of these states that are in red. The states that are in blue are the kind of work in progress states, and states that are in black are the ones that are taking way too long and still haven't passed plans, or in the case of a place like Ohio, are in the middle of a constitutional crisis because they can't set up a plan. With that, to try and make this so that everyone has the ability to view the data to understand what happened, we're putting out all of the outputs for our analysis. And so this is just on the Dataverse and allows for people to just grab it if they don't know what they're doing and just have the outputs and deal with those, where these are kind of common types of outputs like CSVs, right? However, for us, I don't think that goes far enough, just releasing outputs, what really went into that process. And so we've been spending a lot of time really taking these and essentially making templates for these states that demonstrate how did we generate those plans, and making that all available on GitHub. The key there, though, is that this sets up a common template that can be used for any state, for any locality with a smidgen more work because you need to better define a locality than a state, and gives a common set of code that uses the 8 packages from before to prep the data, do the common types of steps of matching elections, then to set up these simulation specific objects and actually simulate and score in one go. We then further just try and document this as much as possible so that what we did in files 1 through 3 is clear, so that other people understand really what we did. The output of that is very nice, is once we have that, there's a nice parameterized using the beautiful distill package for R to actually just automatically create an output for this so that each page has a website. In this case, I was highlighting New Jersey, right? So a place like New Jersey, it's a state right below New York for those who are not familiar with New Jersey. And we're able to just immediately look at the enacted plan in the top left here and see, okay, plans that also satisfy this, here's just 3 more. We've given you 5,000 in the output on the Dataverse, but here are 3 so that you can get a quick sense of what's really going on. We can then use that and do things like, okay, across those 5,000 plans, how many seats did people get? And the beauty is that like the code to generate this, these are the types of reports that are used in litigation and presenting to commissions all the time. The code for doing this is all right there and follows through the website. This type of vote margins is kind of the first thing that we always go to, because very often what we're worried about in redistricting are 2 big things: partisan gerrymandering and racial gerrymandering. Racial gerrymandering is not set up in a way that we could easily check this. You need a lot more pre-work. But for looking for things like partisan gerrymandering, you can get these types of telltale signs just by glancing them at a website like this, where we can see what happened in New Jersey redistricting. If they had competitive seats like we might have expected, you would have had 2 to 3 that were right along this line. Instead, you end up with these 2 particular seats that get packed a little more and give a little more protection to the incumbent Republican and Democrat in those 2 seats by pushing it away from that kind of even line and creating a small Republican and a small Democratic bias in those types of seats. Those types of biases that we can tell by looking at a graph also have in a large literature all sorts of metrics that we pre-compute and put on the Dataverse with this. To wrap up that type of sense, we can then even look at those traditional criteria that are often optional, of things like compactness on the left here, right? So we'd be able to say, well, on average, the plan that they enacted is less compact than what we would have seen, where higher scores are more compact. And on the other hand, right, like, so the numbers of county splits look about what we would have seen. It's about the median, so that those types of things might not be a problem. In a similar vein, with the other side of my work, done some very cool thing that I believe is the first time this has been done for litigation, is we actually were able to take all the software and in the course of a few days, write an amicus brief, which is essentially saying to a court, hey, this is our expertise right here. We noticed you're dealing with this particular issue. As academics with this expertise, here's just some notes on if your thing that you're worried about is possible. And what is very cool about this that I think makes it a little novel is we were able to get the law clinic to agree to put this all on GitHub, so that not just telling the court, hey, this is possible, we're able to say, this is possible, here is every single file that you need to directly replicate it, and here is every single decision because you have the code. Granted, that might take a little more time to get justices who can read our code, but can only go so far. And so with that, thank you guys very much.
That's amazing, Chris. Literally saving American democracy. Does anyone have any questions or comments? This must just be incredibly contentious, right? Like people going after you for advice from either side. Have you had much interaction that is sort of negative and put you off the research topic?
No, I don't think we've had any negative interaction. We've actually been, our group has been, I think, excited to see that in some of these cases now we have both sides using the same set of software and actually getting a nice clean argument over like what are the trade-offs that are being made, so that you actually get to see like, oh, well, this group or this expert witness like sacrifice this particular area to create a Democratic advantage or Republican advantage, and actually get to see them then going back and forth. Because there are so many like details about how communications are privileged regarding those, I've been kind of shielded, I guess, then from getting people who are upset with it. Mostly we hear people who have just like happy questions like, oh, I'm using this. Can you tell me a little bit more about like how this type of thing is implemented? Because the actual details of these cases and the details of people using this, the actual software is often privileged until a case is ongoing.
Are there shiny apps and things that could be developed that would further sort of reduce what we expect of a user in terms of their statistical capacity?
Absolutely, there are, but we have not gotten there yet. It's definitely something that comes up from time to time because like lawyers are very smart people, but often lawyers and judges do not have any statistical training beyond high school type of statistics. So trying to get things to be point and click is a conversation that comes up with many of the stakeholders that like are trying to use this with lawyers and explain it. Yeah, so it's definitely something that I think would be great to implement, but it's not something that we are quite the stage of having anything implemented.
Does anyone else have any other questions or comments, Chris? Are you comfortable talking a little bit about the census? You had a paper with Shura, right?
Oh yeah, yes. On the differential privacy.
Yeah, folks might be just, do you have like I don't want to put you on the spot, so feel free to say no, but like, do you have a couple of minutes just to like give folks a brief overview of that paper or?
Sure, yeah. So in April 28th, 2021, the Census Bureau, just before they were supposed to be releasing the actual data, put out a large set of demonstration data, which is essentially saying, okay, we're implementing a new privacy protocol. You have the data under the old protocol. There's a brand new protocol. How do we actually compare these and understand what's going to happen? Where we started as redistricting simulation kind of experts and that is the large piece of our research, we said, okay, well, it's not super useful to just look at the single enacted plan that's been put into place. What we want to understand is if we sample for, and we picked, I think, 8 states that had interesting reasons to pick them, what actually happens based on the privacy aspect. And so what we're able to do is say, okay, over 5,000 or 10,000 plans, this type of privacy procedure is doing very specific things. Those specific things that we found by running these types of simulation algorithms was that the new privacy protections in the census that are based on differential privacy but have a whole large scale post-processing, so that you don't do things like release negative numbers of people, or say that there are 50 people in a block, but the block group that they live in has less people than that block. There are all sorts of kind of standardization, common sense constraints that are on there. What we find is through that 2-step process, at the end of it, heterogeneous areas, racially heterogeneous, so where it's very integrated, tend to get undercounted, not as a factor of like bad measurement, but as a factor of the privacy procedure. So there's always a concern, right, that we might be undercounting people in an area, but beyond that, the privacy procedure itself actually detracts from those areas. And because the counts need to still add up to the same number, reallocates those people from these heterogeneous areas into these much more homogeneous areas. And so the effect of that is very important for American democracy because we have such strict rules about equal population. That in effect means that those homogeneous areas have more voting power per person, whereas those heterogeneous areas end up with less, because since it's undercounted and you need to still reach the same number of people, you have to put more people into those districts. That's something that I think is still a huge area ripe for research, because we were only able to look at the first the 12.2 demonstration data and the 19.61, which was the final parameters. Final parameters slightly improve over the focus of that paper, and is in the appendix, is that, hey, there's still a problem, but it is improved. It is something I think for especially people who are using census data to be quite aware of, including outside of the United States, as other large Census Bureau type organizations have been trying to take on similar approaches.
Yeah, and just to sort of underscore the importance of the work, I'll just quote the final sentence of your abstract. So while the DAS, which is this procedure that Chris is talking about, which is this disclosure avoidance scheme?
Yes, system
leads to a likely violation of the 1 person, 1 vote standards as currently interpreted. It further does not prevent accurate predictions of an individual's race or ethnicity. So this is the reason, one of the reasons for putting in place this DAS. The paper sort of argues that it's likely not doing that. So important work in a variety of areas. So thank you very much, Chris. Really appreciate it.
Thank you. Happy to be here.